Part 1. The Quiet of the Universe. Close your eyes for a moment. Let your breathing settle. Slow, steady, effortless. Imagine a place without sound, a place without light, without movement, without time as we know it. A place so empty that silence feels almost alive. That is where our story begins. Around 13.8 billion years ago, the universe was nothing like it is now. There were no stars burning in the sky, no galaxies swirling gracefully in the dark, no planets circling suns. And yet, everything we see today was already there, waiting, folded into a single, impossibly dense speck of energy. Then, in a moment beyond comprehension, space expanded. Time began. This was not an explosion the way we imagine one. It was more like the universe taking its first breath. Matter began to spread out. Particles emerged from the void, free to combine, free to become something greater. Hydrogen formed, then helium. Simple elements drifting through the growing dark. As the universe stretched wider and colder, these elements gathered into clouds, vast, silent oceans of dust and gas. Within them, gravity began its quiet work. Hold your breath a moment. Feel the pause. Even the universe took its time. Part 2. The Birth of the Sun. Among the countless clouds drifting through the newborn cosmos, there was one, just one, that would one day give rise to our home. This cloud rotated slowly, pulled gently inward by gravity. As it shrank, the center grew hotter, brighter, denser. What was once a silent mist became a forming heart. Eventually, the pressure in the center grew too great, and hydrogen atoms fused into helium, releasing light. A star ignited. We call it the sun. Around this new sun remained a swirling disk of dust, rock, and ice. Tiny fragments, barely more than grains at first, began to collide, stick, and form larger bodies. These infant worlds were rough, unstable, and constantly changing. But they were the seeds of the planets we know today. Among them, one small body began to grow in the outer region of the inner solar system. It gathered more rock. It endured thousands of collisions. It was battered, melted, and reshaped. This was the beginning of Mars. Take a slow breath in and let it go. Just like the universe shaping itself over eons, you have nowhere else to be but here. Part 3. A Young Mars. When Mars first came into existence, it was nothing like the quiet, frozen desert we see today. Roughly 4.5 billion years ago, the young planet was a glowing sphere of molten rock. Volcanoes spewed lava, meteors slammed into its surface, and oceans of magma churned beneath a restless crust. The sky may have been orange or dark red, thick with dust and volcanic ash. Countless impacts from space delivered new materials, metals, minerals, and perhaps even the most basic ingredients of life. As the bombardment slowed over millions of years, Mars began to cool. A solid crust formed. Lava hardened into mountains and plains. Beneath the surface, iron-rich minerals began to oxidize. A simple chemical reaction with profound consequences. Iron turns red when it rusts. Slowly, patiently, the dust of Mars became tinted with iron oxide. The rocks reddened, the soil darkened, and Mars earned its name as the Red Planet. Take another slow breath. The universe moves on a timescale far beyond human life, and in this moment, you are drifting with it. Part 4. Mars takes an atmosphere. As the interior of Mars continued to cool and settle, gases trapped within the molten rock pushed outward. They escaped through cracks and volcanoes, forming a thick, early atmosphere. This first atmosphere was much heavier than the thin whisper Mars carries today. It likely contained carbon dioxide, water vapor, nitrogen, and traces of other gases. With these gases swirling above it, the young planet changed again. Clouds condensed. Heat was trapped. And for a time, no one knows exactly how long, Mars may have been warm enough for liquid water to exist on its surface. Imagine rain falling on a planet that today is bone dry. Imagine streams carving paths through rock. Imagine lakes forming in low basins, held under a protective sky. Scientists believe this age truly happened. We see its traces today. River valleys, deltas, lake beds, sediment layers. They are scars on the ancient surface, proof etched in stone. Let your shoulders loosen. Let your breath smooth out. You are wandering through billions of years in seconds, and yet everything feels unhurried. Part 5. A planet that could have been. During this early period, Mars was not just warm, it may have been Earth-like. Temperatures stayed above freezing in many regions. Volcanoes provided heat from below. A magnetic field may have protected the atmosphere, shielding Mars from radiation and solar wind. Some scientists believe the planet may once have each however today enough to wrap around large regions of the northern hemisphere. Part 6. The Age of Water. Now, let's drift into a time when Mars held one of the most precious ingredients in the universe: liquid water. After the planet cooled and its thick atmosphere stabilized, the air trapped warmth close to the surface. Rain likely fell, perhaps not every day, but often enough to shape the world. Rivers snaked across the terrain. They cut valleys, carved canyons, and smoothed stones. Some ran for hundreds of kilometers. Where the rivers slowed, they dropped sediment, a fine powder of crushed minerals. Those sediments collected in wide, quiet basins and formed deltas. One of these ancient deltas is now visited by NASA's Perseverance rover. Billions of years ago, it may have been a shallow, calm lake. Water lapping at muddy banks. Sunlight filtering through a hazy sky. Minerals settling slowly to the bottom. Farther north, scientists believe that a vast ocean once filled a low-lying plain. Its shoreline still exists in subtle curves, a fossil coastline etched into the planet. Imagine standing on the shore of that sea, a cold wind from the north, volcanic peaks to the south, thin clouds drifting in what once was a thicker sky. If life emerged anywhere on Mars, this watery era would have been its birthplace. Slow your breath again, in and out, like the rhythm of ancient Martian waves. Part 7. The Fading of a Planet. But nothing in the universe remains the same forever. Deep inside Mars, something crucial began to change. Its molten core, once spinning vigorously, gradually cooled. On Earth, our active core drives a magnetic field, a shield that protects our atmosphere from being stripped away by solar wind. Mars slowly lost that shield, and once the magnetic field faded, the sun began to peel away at the Martian atmosphere, atom by atom, layer by layer. Winds in space are invisible, but they are powerful. Over millions of years, they thinned the air until very little remained. With less atmosphere came colder temperatures. Liquid water could no longer stay on the surface. It froze into ice or evaporated into space. Rivers dried. Lakes vanished. Oceans became nothing more than minerals left behind. The planet shifted from a world of rain clouds and running streams to a place of dust storms and empty valleys. A transformation was complete. Mars turned from blue and promising to red and silent. Take a gentle breath. Let the melancholy pass through you. Even planets experience endings. Part 8. Could Mars have supported life? And yet, that silence is not the end of the story, for the most haunting question remains. Could Mars once have supported life? If microorganisms emerged early, perhaps in shallow lakes or in geothermal vents beneath the crust, they may have thrived in warm, wet places for hundreds of millions of years. Even after the surface dried, life could have retreated underground, where liquid water may still exist today, trapped in porous rock or warm pockets beneath ice. Rovers and landers have found tantalizing clues: ancient lake sediments, organic molecules, methane spikes in the atmosphere, minerals that form only in water. None of these prove life existed, but together they whisper possibility. One meteorite discovered in Antarctica, believed to have been blasted off Mars long ago, contained tiny structures that looked like fossilized microbes. Scientists still debate it, a mystery locked in stone the size of a hand. Imagine for a moment that somewhere beneath the surface, in a dark, salty pool, simple microbes once swam, or still survive. If so, Mars would not only be a dead world, but a world holding secrets. Let the thought settle gently. A universe with more than one spark of life feels a little warmer. Part 9. Modern Mars. Today, Mars is cold and quiet, but it is far from empty. Almost every year, we send new machines, curious metal explorers, to roll, dig, fly, drill, and listen. Curiosity has roamed Gale Crater since 2012. It has tasted Martian soil, measured radiation, and found chemical ingredients of ancient water. Perseverance, its younger sibling, searches for biosignatures, tiny traces of ancient life. It collects samples that one day may return to Earth. Ingenuity, a tiny helicopter, proved for the first time in history that a powered aircraft can fly on another planet. Orbiters circle above, mapping ice sheets hidden beneath dust, tracking storms that grow into global veils of wind and sand. We now know that Mars stores enormous reserves of frozen water, not just at the poles, but beneath mid-latitudes and in sheltered walls of craters. Some scientists believe that lava tubes, long, hollow caves formed by ancient flows, may still hide frozen lakes or warmer ground. Mars may look barren, but it is alive with scientific promise. Breathe in the anticipation. Science is patient, and Mars rewards patience. Part 10. The Future of Humanity on Mars. Now, lift your eyes from ancient history and drift forward into what may someday be. Mars is the only planet in our solar system where humans might realistically live. The challenges are immense. Thin atmosphere, no oxygen to breathe, radiation from the sun, low temperatures, dust that gets into everything. But even so, engineers and dreamers imagine solutions. Habitats built underground or beneath ice, shielded from cosmic rays. Greenhouses pressurized with air, where hardy plants stretch toward artificial suns. Mining water from ice to make oxygen, and even rocket fuel. One day, humans may walk in the shadow of Olympus Mons, the largest volcano in the solar system. They may build bases at the poles, where ice lies just beneath the surface. They may watch a sunset that glows blue, not red, for on Mars the colors reverse. Some dream even bigger, terraforming, warming the planet, thickening the atmosphere, bringing rivers back to ancient valleys. It is a distant dream, perhaps centuries or millennia away, but humanity has always looked upward. As you breathe softly now, remember that exploration begins in quiet awe, just like this moment. Part 11. The First Human Footsteps. Imagine the silent surface of Mars. No wind for the moment, no motion, just dust and rock and ancient mountains watching over a planet that has slept for ages. Now imagine a ship descending from the sky, its engines whispering into the thin air. After months of travel across empty space, a crew of explorers steps out. Their boots press gently into red soil no living creature has touched before. The first imprint sinks only a few centimeters, but symbolically it is vast, a bridge between two worlds. They speak into their radios, their voices trembling with awe and fatigue. Their words are simple. We made it. Around them stretches a horizon sharper than any on Earth, devoid of haze, etched against a copper sky. Nothing stirs, yet everything feels full of potential. Let your breath soften. Pause with that first step, the start of a human chapter on Mars. Part 12. Living away from home. Life on Mars would be unlike life anywhere else. Imagine waking inside a small habitat with rounded walls and gentle lights. Outside the windows is a world of dust, sand dunes, and distant cliffs. Every detail of survival is deliberate. Air must be made, filtered, and preserved. Water comes from melted ice mined beneath the surface. Food grows in soil enriched by science under lamps that mimic sunlight. The people here will live slowly, carefully, mindfully. They will check seals, measure oxygen, maintain machinery. There is no rushing on Mars. Everything is planned. Every action matters. Breathing becomes an act of gratitude, a reminder that life persists even in places thought impossible. Feel your breath deepen, as if you are in that habitat, watching dust swirl outside, safe and calm inside. Part 13. The Psychological Journey. Mars will not only test our technology, it will test the human mind. Far from Earth, surrounded by a desert that stretches for thousands of miles, settlers may feel both awe and loneliness. No trees whisper in the wind, no oceans roar. Skies rarely change. The nearest natural sound is your own breathing. To find comfort, humans may carry memories, voices recorded from home, photos of oceans and forests, plants growing in small pots like symbols of Earth. Inside the quiet, the mind slows down. People may write, dream, reflect more deeply than ever before. Some may discover that distance sharpens perspective, that being away from Earth brings a new appreciation for it. Others may feel homesick for colors, sounds, and scents Mars cannot offer. But in that balance, between longing and wonder, human resilience will grow. As you listen, notice the calm forming in your own thoughts. Silence can be a companion. Part 14. Terraforming Dreams. Human beings rarely stop at survival. Once footsteps touch a new world, the imagination begins to stretch forward. Terraforming Mars is one such dream. To terraform means to transform, to reshape a planet so it could support life more easily. It might begin with thickening the atmosphere, releasing greenhouse gases to warm the surface. Next could come melting polar ice to create rivers again. Plants, engineered or resilient, could take hold, slowly turning carbon dioxide into oxygen. Generation after generation, Mars might shift from red deserts to patches of green. Not quickly, not in a decade, or maybe even in a century, but across the slow turning of time, humanity could share the role that volcanoes and oceans once played. And perhaps, one distant day, someone could stand outside on Mars without a suit and breathe freely. This dream floats between science and poetry. Let it linger like a soft haze without needing an answer. Part 15. A Return to the Red Wilderness. Yet even within that dream, Mars will always keep part of itself. There will always be bare slopes of rust-colored rock, immense valleys carved long before humans rose on Earth, and quiet craters untouched for billions of years. The planet's identity is not ours to overwrite, only to learn from. Explorers might journey into Valles Marineris, a canyon so vast it makes the Grand Canyon seem small. They may climb frozen dunes beneath a thin blue sunset. They may walk under Olympus Mons, a volcano as tall as 3 Mount Everests stacked. The wilderness of Mars will remind humanity that exploration is never ownership. It is a conversation between the fragile and the ancient, the curious, and the silent. Settle into your breath now. Picture that vast red wilderness. Feel yourself shrinking in its immensity, but not afraid. Just calm. Just present. Part 16. Beneath the surface. While the surface of Mars is cold and exposed, the underground world tells a different story. Beneath the dust and rock, temperatures rise slowly. Ice hides in layered pockets. Salty water may flow in thin films between grains of soil. Part 17. The search for life resumes. Even after decades of robotic missions, the question remains open. Is Mars alive? Future explorers will carry tools Earth rovers cannot. They may dig meters below the surface, where radiation has not erased ancient chemistry. They may melt boreholes into ice sheets to search for briny pools. They may collect samples from layers untouched for billions of years, preserved like pages in a planetary diary. Scientific instruments will look for complex organic molecules, fossil-like structures, chemical imbalances that hint at biology, signs of metabolism, even faint ones. Perhaps the answer will be found quickly, in a microscope's field of view, a cluster of shapes where none should exist. Ancient lava tubes, long tunnels formed by flowing magma, stretch for kilometers under the ground. Some are large enough to house entire cities protected from radiation and storms. Inside these silent caverns, humans might build their first true Martian homes. Warm, pressurized, self-contained. Lights would glow gently against curved rock. Hydroponic gardens would whisper with green life. People would sleep lulled by the hum of air recyclers, dreaming of red horizons above them. Part 18. A day in a Martian colony. Picture an ordinary day for the early settlers of Mars. The morning begins with sunrise filtered through dusty air, a pale light more muted than Earth's dawn. Inside the habitat, alarms chime softly. Crew members wake slowly, stretching beneath recycled warmth. Breakfast is simple. Plants grown in nutrient gel, water extracted from ice, perhaps a few luxuries brought from home. Outside, teams travel in pressurized rovers across silent plains to repair solar panels, install sensors, or search for new ice deposits. Communication with Earth introduces delay. Messages arrive minutes later. They're of the realist conversation. Part 19. After humanity leaves. Perhaps humans will live on Mars for centuries. Perhaps they will transform it into a second Dale of life. Or perhaps, one distant day, they will depart. Technology may evolve, civilization may shift, and Mars could be once about to the silence it knows so well. But traces of humanity will remain, footprints fossilized in dust, buildings half buried in sand, caves lined with forgotten gardens, tools waiting perhaps for hands that will not return. Future explorers, Earthborn or otherwise, might someday find these relics and groan who we were, and has an extraordinary ability to preserve its history.